Okay, so I'm going to start by looking at some of the notes and handouts that you have for, in particular, the normal distribution. So some of these concepts I may have talked about in the lab video. It's kind of hard for these things not to overlap. Um, but we have the normal distribution. When we classify a distribution as normal, it means something really, really specific. So it means a distribution, a variable is normally distributed if it follows these really specific characteristics. The mean, first of all, is going to live right in the middle here. And then we have a particular standard deviation. In what's called the standard normal curve, the mean is 0, okay, and standard deviation is 1. So if you have a z-score of 1, it means that you are 1 standard deviation above the mean. That's good, right? If your z-score is -1, it means that you are 1 standard deviation below the mean, okay? And then there's some much more specific characteristics that a normal distribution is going to follow. And that's where we get into this 68, 95, 99.7 rule. So here we have Pam and we have Jim, and we want to compare the two of them. So the best way to compare them, since Pam scored an 1800, Jim scored in here on a completely different scale, a 24, we can't compare them. But if we know Jim is a certain number of standard deviations above the mean, right, we could do 24 minus 21. He's 3 points above the mean, and that's with a standard deviation of 5, so he's 3/5 of a standard deviation above the mean. Pretty good, right? Pam's also above the mean. Well, she's 300 points above the mean, but in her distribution, the standard deviation is a 300. So she has a z-score of 1. She's 1 full standard deviation above the mean. Jim's not quite a standard deviation above the mean. So we would say relative to the rest of their groups, Pam did a little bit better. Okay, when we standardize them. See how she lives 1 standard deviation above the mean, and Jim is 0.6 above the mean. Okay, now what we can do with z-scores in a normal distribution is we can turn them into percentiles. In other words, we have here how, let's take Pam because that's going to be a little bit easier. Pam is 1 standard deviation above the mean. So the empirical rule, or the 68, 95, 99.7 rule, says this. From 1 standard deviation below the mean, which is right here, to 1 standard deviation above, is going to contain 68% of all of the observations, right? 68% of everybody. And think about that in your daily comings and goings, right? Like, suppose a variable like height, right? Most people, like if, whatever the average height is in a standard deviation, if somebody is 3 standard deviations above the mean in their height, that is an unusually tall person. You probably don't see them very regularly. But if somebody is a standard deviation below the average height up to a standard deviation above the average height, we see those people all the time. In fact, we see them 68% of the time. Okay? Somebody is 2 standard deviations below the mean. Well, that's certainly a much shorter person. It's only about 2.5% of the population is that short. And then 2 standard deviations above the mean, that's an unusually tall person. So guess what? People who are anywhere from 2 standard deviations below the average height to 2 standard deviations above, we're going to see them 95% of the time. Okay, it's going to be really unusual to see somebody who's more than 2 standard deviations above the mean or less than 2 standard deviations below the mean. Those are going to be really unusual. That's what the 68, 95, 99.7 rule means. So if you can bear with me, if 68% of the data lives from 1 standard deviation below to 1 above, see how the curve is symmetric? We could split that in half, which means 34% lives right here from 1 below to 1 above, and another 34% lives from 0 to 1. If I shaded a bar here, from the average to 1 standard deviation above the average in a normal distribution is 34%. Where did I get the 34% from? 68. 68 live here. 68 divided by 2 would be 34 in here, 34 in here. Okay, so watch. 0 is the mean. 50% of all observations live below the mean, right? 50%, half below, half above. So take 50% and 34%, and that's about 84%. So That's something that we want to do next. We want to be able to calculate percentiles using this normal distribution, right? So here we have the same score. The mean was 1,500. The score was 1,800 and a standard deviation of 300. So we can use technology, which is I'm going to show you in a second, or we can use one of these tables. And you can see if you use the table and you find somebody lives one standard deviation above the mean, that is about the 84th percentile, right? 0.84. We have tables to use. I want to focus this on using Excel. So how would I do this on Excel? Remember, I need the mean, 1,500. I need her score, 1,800, and then the standard deviation. Okay, so let's check it out. Excel is going to work just like those tables. It's always going to do an area to the left. So I'm going to hit equals. I'm going to start typing in normal. Okay, and this first one comes up, normal distribution. I'm going to say, sounds good. So it asks, what's the x value? Well, what was her x value? It was 1,800, right? What is the mean of her distribution? 1,500, okay? What's the standard deviation of that distribution is 300, and we do want cumulative, I'm sorry. So it's going to be true on cumulative here. I want the whole area to the left is exactly what I want. Okay, so when I click true there, 0.841345, right? Okay, so here's an even easier example of this from the homework. All right, first question. Probability that a z-score is below negative 1.35. So try to picture what that means. Here's a z-score of negative 1.35, right, down here. So the probability that somebody's z-score is lower than that, right, let me just double check. Yeah, less than, right? Less than negative 1.35 would be the area to the left of 1.35. If we could mark that here and shade it in. Anytime I try to draw on here, things usually go sideways, but I'll give it a shot. So we're talking about negative 1.35 would be somewhere around here. We want to shade that area in, okay? So it will be that area or that probability in there, all right? So Excel will do that for us directly. We can find that probability directly with Excel like we just did. I'm going to go equals, okay? And think about what this number should be. If you get a number that's bigger than 0.5, you should know something doesn't seem right with that. I start typing in normal. Okay, and now what do we have? Negative 1.35, that was my x value. What's the mean? In a standard normal distribution, it's even easier. The mean is always 0, and the standard deviation is always 1. And do we want cumulative? Yes, we do. Okay, so I have 0.0885. Okay, now next one's a little bit trickier because it doesn't work the same way that we're used to working this. Notice it now says the probability that z is greater than 1.48. Okay, so what's that going to look like? Z greater than 1.48. Well, 1.48 is going to live over here, like around 1.5, right? And I want this area that's bigger than that. All right, well, you've seen already that what Excel always gives us is areas to the left. So there's two ways I could do this. I could let Excel get me the white unshaded area, and I could subtract that from 1. Or we could realize that over here at negative 1.48, the area below that, right, the area below negative 1.48 is the same as the area above 1.48. The curve is symmetric. Okay, so we could do it either way. I'll show you that both ways would work. So if I come over here, and remember, this number, we should expect this number to be less than 0.5 also, right? So I want the area above 1.48. So watch what happens if I go equals, start typing in normal. Okay, so if I type in here 1.48, comma 0, comma 1, and true, remember what's going to happen. This is not going to give me the right answer. This is going to give me the area to the left or below 1.48. I want the area up above it. It's okay because I can get that area by just doing 1 minus that value. Okay, 0.0694. All right, or what could I have done here instead? Equals, start typing in normal. Instead of just going with 1.48 and I want the area above it, let's use negative 1.48. Let's get the area below negative 1.48. That's going to be the same as the area above positive 1.48. and we still want true. Okay, 0.069, same answer, right? 0.0694. Okay, now even tougher, right? Now I want to go in between two numbers, negative 0.4 to 1.5. What's that look like? Negative 0.4 is going to live somewhere over here, right? Here's negative 0.4, right? And I want to go from there all the way up to 1.5. So now the area that I want is like this shaded area in here. Okay, what's that probability? All right. So what can Excel do here? Excel could give me the area to the left of each of these, right? That's all it's going to do. It's not going to get this directly, so we have to be clever here. Excel would give me this white area here, the area less than negative 0.4, and Excel will give me the area less than 1.5. So think about it. If Excel gives me this area less than 1.5, it's giving me too much. It's giving me all this stuff that I don't need. Well, what's that? That's the area to the left of negative 0.4. So all I'm going to need to do is subtract those two, and that'll give me the area in between them. So let me just go back and look at the numbers real quick so I make sure I remember in my head. Yeah, negative 0.4 to 1.5. So I can get both of those numbers with Excel, but I'm going to have to subtract them. So we go equals norm. Okay, and I have negative 0.4, 0, 1, and a true. Okay, remember that's the area to the left of negative 0.4. Right. Then I have equals norm dist, 1.5, 0, and 1, and true. Okay, so remember this number was too much. All right, this is the whole area we don't want, right? This is point. So what I do is subtract these two, and I'll get the area in between them equals 0.9332 minus 0.3446. Okay, and now the last one, z greater than 2. So we're going to have to be clever with this one as well. Okay, greater than 2, but it was an absolute value, right? So absolute value of z is greater than 2. So a little bit of algebra review here. If the absolute value of the z-score is greater than 2, so you could be talking about 2.1, 2.2, 2.3, right? 3, 5, all these numbers bigger than 2, but absolute value bigger than 2 means that negative numbers are in the game as well, right? We got positive numbers who are bigger than 2 out here, but these guys are going to have absolute values bigger than 2 as well. So we meet both of those two little areas, all right? So what can we do? A couple of things. We could find the area below negative 2. I think that's the easiest thing to do. Just do our normal distribution. Find this blue area that's less than negative 2, and then just double it. I really think that's the easiest way to do it. Everything else is going to be more steps. If you find the area less than 2, okay, then you're going to have to subtract from that. It's just going to get too complicated and messy, right? So I think your best bet is to find the area less than 2 and then just double it. Multiply it by 2 once we have it. Okay, so to get that area that's less than 2 is going to be really easy. We go equals normal dist, and we have negative 2, 0, 1, and we want true. But remember, I have to double this, okay? So 2 times that guy, 0.0455. Okay, so hopefully that is helpful. I'm going to post another video soon, so there should be 3 videos total. The next one I'm going to try to do a couple things with, and then I already posted one on the binomial setting. All right.